How to write skeleton equations in chemistry. First few things you need to know is that a chemical equation is simply a sentence that shows chemical changes using formulas. So here is an example of a chemical equation. 2 moles of sodium in the solid state react with 1 mole of chlorine in the gaseous state to form 2 moles of sodium chloride, and this would be in the solid state. And a chemical reaction simply is a reaction in which a substance is changed into a new substance. So here the reactants, sodium and chlorine, change into the products, sodium chloride, and so the substances change, become different substances, so that is a chemical reaction. Also, chemical reactions use symbols to indicate the state of a substance. For example, if a reactant is in the gaseous state, we use the letter G. If it's in the solid state, we use the symbol S. If it's in the liquid state, we use the symbol L. If it's in the aqueous state, we use the symbol AQ. Do not confuse the liquid state with aqueous state. A liquid is a pure substance, such as pure water can be in the liquid state, or pure methanol can be in the liquid state. But a substance dissolved in water is going to be aqueous. For example, if the substance sodium chloride is dissolved in water, then it is an aqueous substance. So aqueous means dissolved in water. Also, if there are things that are present that do not enter into the reaction but are necessary for the reaction to occur or speed up the reaction, these must also be indicated in the skeleton equation. These we call catalysts. Again, they are substances which speed up a chemical reaction but are unchanged. For example, if this reaction is catalyzed by platinum, then platinum is not a reactant, so we don't put it on the reactant side. It is not a product, so we don't put it on the product side. We put it above the yield sign or the arrow to indicate that it is something that is necessary for the reaction to occur. It speeds it up, but it is neither a reactant nor a product. Same thing for the second one. If manganese dioxide is a catalyst for this particular reaction, then we put it above the yield sign to indicate that that is a catalyst for that particular reaction. Also, to write skeleton equations, we must understand that there are some elements that are diatomic, meaning two-atomed elements. There are 7 of them, and if you think of the number 7 and we force this a little bit. If we put the number 7 here, starting with nitrogen, these are the 7 diatomic elements: nitrogen, oxygen, fluorine, chlorine, bromine, iodine. That makes up 6 of the 7. The 7th one is hydrogen. So all of these elements are diatomic, must be H2, N2, O2, F2. They do not exist as monatomic elements. That is, when they are by themselves, they are always H2, N2, and so on. For example, if you think of chlorine, if it's part of a compound, then it is not diatomic, but again, it's only as elements that is diatomic. So if we mention chlorine gas or the element chlorine, that'll be not Cl, but Cl2. It's a diatomic element that is by itself. It always exists as 2 atoms joined together. So how do we write skeleton equations? Again, skeleton equations show the chemical reaction. They are not balanced. You must have all the reactants on the reactant side, products on the product side, and the formulas and states must be indicated. So here we have aqueous sodium phosphate. So the sentence tells us the first reactant is aqueous sodium phosphate. And so here is aqueous sodium phosphate. So you've got 3 sodiums because it's a 1 plus. The phosphate's a 3 minus, and it is aqueous, so that is the correct unit formula for sodium phosphate. That is going to react with the aqueous lead to nitrate. So there is the lead to nitrate in the aqueous state. And it's going to form the precipitate lead to phosphate. And so here's the precipitate. Note it is now indicated that it is in the solid state and aqueous sodium nitrate. So this is the skeleton equation, indicates the reactants and products, all the formulas written correctly, and the states of the substances are indicated. Here's another skeleton equation. Here we have nitrogen gas. Remember, nitrogen is one of those diatomic elements, N2. It is going to react with hydrogen gas, another one of the diatomic elements, and it's going to form ammonia gas. So going to form means we put that on the product side in the presence of iron as a catalyst. So we need to indicate iron as a catalyst to complete this skeleton equation.